Okay, so for lesson 6.2.2, how do shapes change? We're still talking about dilations, where yesterday we just looked at how we make them larger and smaller by multiplying coordinates by a specific number. Today we're going to look about how we undo a dilation, so looking at a shape that's already been dilated and finding out what its pre-image looked like. So the first problem that we're going to look at is in your ebook, problem 6-5-2, undoing a dilation. So in yesterday's lesson, you looked at dilations and multiplied each of the coordinates of a shape to change its size. Now you explore how to undo dilations. So Charlie multiplied each coordinate of the vertices of a shape by 4 to create the dilated shape below. So they're talking about this shape right here, or this one right here. Same one. If Charlie multiplied to find this shape, what operation would undo its dilation and why? So then we think about just what our basic knowledge of operations are. We think about the inverse operation of multiplication, and that is division. So you can click on your Student E tool, and it will look like this. And so you have some hints over here to the side. I guess I should have made my barrier wider, but I didn't. So, move this tab over maybe. There we go. Okay, and so what you're going to do is you're going to think about, it tells you some steps here about what to do. This is what I just read. How do we undo it? We talked about how dividing undoes multiplication. So this is what the shape looked like after he dilated it. So now we want to see what the original shape looked like. So thinking about what each of these points is, then I want to divide that by 4. These are not the correct coordinates. These are just where these dots happen to be sitting at the moment. So if I look at this coordinate here of -4, 4, and divide each of those by 4, then my new coordinate becomes -1, 1. So I'm going to put that coordinate there. And then I'm going to look at this coordinate up here, which is 4, 8. Again, dividing that by 4 gives me 1, 2 as a coordinate. So 1, 2, so that's where my B goes. And then we'll look at this coordinate here, which is 8, 4. So dividing each one of those coordinates, 8 and 4 by 4, gives me 2, 1. And then my last coordinate down here, which is 4, -4, which would give me 1, -1. Now, in order to connect those dots, you'll see you have a table here. So you're going to put in the coordinates in order that you see them. So -1, 1, 1, 2. See how they will start connecting to 1, -1, 1. And then to connect, whoops, my bad. This should be 1, -1. Now to connect this point to this point, D to A, you're going to go back to your original point of A, -1, 1, and it will connect those points. So now we can see this was our pre-image before it was dilated, which makes sense because we divided that by 4, or it's 1/4 of the size of this shape. So you can think of that as we divided each one of these by 4, or we multiplied each coordinate times 1/4, which is what we did yesterday. The next problem that we talked about is problem 6-5-3. This one is about Elena, who is also working on dilations, and she's wondering what would happen if she multiplied each coordinate of a shape by 1/3. So she does that, and she creates a shape using these coordinates. So those are right here. Okay. So once she has done that, so she's graphed her points of -1, 1, -1, 1, sorry, negative 1, negative 1, negative 1, 1, 1, 2, and 2, negative 1. Now she's thinking, well, she's multiplied each of its original coordinates to get this shape. So she's made her shape smaller, which makes sense because she's multiplying by something less than 1. So we want to think about, well, what did her shape look like before she did that? So when we multiply by a 1/3, that also means we're dividing by 3. So we would want to do the opposite or the inverse to find out what her shape looked like before to undo this division. So then we would want to multiply each of her coordinates by 3. So in order to do that, I'm going to look at this coordinate here, which has a coordinate of negative 1 and 1, and I want to multiply that by 3. So then I would get, so it shows you right here what her original coordinates were. I'm going to multiply this negative 1, negative 1, which is apparently is this coordinate here. Multiply that by 3, and I'm going to get negative 3, negative 3. So it's going to put a dot down here in red for me. Now I'm going to look at this next coordinate, which is negative 1 and 1. Multiply those by 3. I'm going to get negative 3, positive 3. My next coordinate is 1, 2. Multiply each of those by 3, so I get 3 and 6. And my last coordinate is 2, negative 1. Multiplying those by 3, I get 6, negative 3. And then I want to start at the coordinate that I began with, negative 3, negative 3, to close the shape. So now we can see that after she undoes her dilation of multiplying all the coordinates by 1/3, this is what her original shape looked like. It was larger, which makes sense because if she dilates a shape by 1/3, it's going to make the shape smaller. So it made her original shape smaller. So in order to see what her original shape was, she'd have to do the opposite. So she multiplied by 3. The last problem we looked at, first we read through the changing of the shape. We read through all of these things, and we talked about with our partners about what you think would happen if we only multiplied the x coordinate by a number, or if we only multiplied the y coordinate by a number. So that takes us to another Desmos activity, which is here, the student tool. So you can click on that and do it alongside with me. So the first of our directions is dilate each coordinate by a shape of the shape PQRS by multiplying each x coordinate and y coordinate by 4. Graph the dilated shape on the same graph using a color other than black. So we're multiplying each of these coordinates. They were nice enough to put the coordinates in there for me. So P is 0, 2. I want to multiply both of those coordinates by 4. So I would get 0, 8. Q, if I multiply that by 4, since it's 6, 7, I'm going to get 24, 28. And then R is 4, 0, so then I'm going to get 16 and 0. And then SS is going to stay at 0, 0, and then I'm going to go put the coordinate I started with back in to map my shape. Okay, so this is what this shape looks like dilated or by 4 when we've multiplied that by 4. So now we want to come back to the original shape, so this shape here, and this time multiply only the x coordinate by 3 and leave the y coordinate the same. So when I look at so this is a new table for a new shape. It's going to be a different color of blue. So now we're only going to multiply the x coordinate. So by 3, well, 0 times 3 is still 0, so this coordinate actually stays the same. I'm going to multiply my 6, 7 coordinate by 3, just the 6 by 3, so I get 18 and 7. My R point is 3 times 4, so that's going to be 12. We're going to leave the Y alone, and then 0, 0 stays the same. And then we're going to go back to 0, 2, so we can close the polygon. And so we get a shape that looks like this. So now we don't even have the same shape anymore. So when we've done that, it makes our shape look different. So we do not even have a similar shape anymore, and we definitely do not have a congruent shape. Now, the one thing I did for the kids in class after I did this was I had them actually use Play-Doh. Change this color, maybe. I don't know, maybe not. But then I multiplied the y's, left the x's alone, but multiplied the y's by 2. So this time I'm going to do 0, and then if I multiply that 2, that becomes 4. And then the 6, 7 is going to be 6, 14. The R, which is 4, 0, becomes 4. It stays 4, 0. And so does this one. It becomes 0, 0, and then we're going to connect back up to 0, 4. So when I do that, you can see it didn't, I don't know, I'm not doing it right apparently, but I wanted to make that a line. If we would look at this shape, if we were connecting these dots, again, we don't have the same shape, so we don't even have a similar shape anymore. But what I wanted to see is when we only change the x's, or when we only multiply the x's, it kind of squishes the figure down. See, this got shorter. But when we multiplied the y's, we stretched the figure out. It got taller, but it stayed the same width. So that's what I was wanting wanting the kids really to see when we mess around with changing the axes. The other part of the lesson that I would like you to look through is the vocabulary of what it means to have a similar shape, a congruent shape, and what corresponding sides and those kinds of things mean. And that pretty much wraps up our lesson for today, at least, on dilations.